Okay, 2.5 solving equations. Now, in RenWeb on the lesson plan it says 2.6. I thought we already covered 2.5, and I realized we hadn't. Okay, so I'm going to try to get it changed to where it says 2.5. But if your parents are some of those that, or you go on and you don't look and you'll do the wrong assignment. Okay, so make sure you take good notes. Make sure at the end when we give you the assignment that you write down the assignment. Okay, because it will say, as of right now, it says 2.6. We'll do 2.6 tomorrow instead of today. But what we're going to talk about is solving equations that have addition or subtraction in them. Okay, so for example, if I had the equation a minus 5 equal 8. All right, so if I have a minus 5 equals 8, okay, to solve equations, to solve addition and subtraction equations, you must do the inverse operation. Okay, of what is being done in the equation. Okay, so for example, this right here, in this equation, we're doing subtraction. Okay, so the inverse of subtraction is addition. Okay, now, so that means this. A minus 5 is equal to 8. Okay, if I do the inverse operation, what am I doing in this problem? What am I doing to A? What operation? No, what am I doing in the equation to A? I'm subtracting. Now, what am I subtracting? I'm subtracting 5 from A. That is correct. So the inverse of subtracting 5 would be to add 5 to both sides. You add 5 here, and we add 5 there. Now the 5 here cancels out. Okay, because if I take, in other words, this right here, if I have A minus 5 plus 5, well, it doesn't matter what A is. If I subtract 5 from it, but then I add 5 back to it, don't I end up with the same number? In other words, let's say it's 10. If A is 10, what's 10 minus 5? Plus 5. 10, right? You end up with the same number. Okay? So that's why you can do the inverse operation and do it to both sides, and it doesn't change the equation. Okay? So when I do that, this cancels, like we said. What is 8 plus 5? 13. So that means A, because that's the only thing left, is equal to 13. And that's your answer. Okay, now that's a very simplistic example. Okay, there's no negatives in it. There's no anything but just simple mathematics. Okay, let's look at another one like that has addition in it. Let's go x plus 7 equals 12. Okay, so here's what we're doing. We're adding. So we have to do the inverse of adding, which is to subtract. Okay, we're adding 7, so we must subtract 7. So x plus 7 equals 12, and I subtract 7 from both sides. Okay, well, x plus 7 minus 7 cancels out. leaving me with x. 12 minus 7, that right there is what? 5. So x is equal to 5. Now, let's look at that same problem, but let me change one aspect of it. Let's say we had x plus 7 equal negative 12. Okay? The process of how to solve it doesn't change. I'm adding 7, right? Yeah. What's the inverse of adding 7? Subtracting 7. So you still subtract 7 from both sides. Over here it cancels, leaving me with x is equal to negative 12 minus 7. This is where it changes a little bit. Okay? I have to change that to addition, do the opposite of positive 7, which is negative 7. And so that gives me x is equal to negative 12 plus negative 7. What is negative 12 plus negative 7? Negative 19. When you have two negatives and you're adding, you simply add the two numbers together and keep the negative sign. I changed it to addition. Okay? So let's say, let me give you one other example. Let's say it was x plus negative 7 equal negative 12. Now, most of the time, if they're going to do that, they're going to put it in parentheses like that. They're not going to leave it by just x plus negative 7. Okay? So, I have to subtract negative 7 from both sides. Okay, and what that gives me is these two cancel, because I'm doing the inverse operation. It gives me x is equal to negative 12 minus negative 7. Okay, well that means change that to addition, do the opposite of that, which is 7. So negative 12, x is equal to negative 12 plus 7. What is negative 12 plus 7? Negative 5. Okay? So it's the same basic operation in every equation, but making one of the numbers negative or positive ends up affecting the final outcome of how to do it. Okay? Now, I could have done the same thing here. X plus 7 equal 12. Subtract 7 from both sides. That cancels, leaving me with x is equal to 12 minus 7. Well, I can, honestly, we need to probably change that to 12 plus negative 7, because we're supposed to change all subtraction to addition. The reason I didn't is because you know how to do 12 minus 7. Okay, that's the reason I didn't change it, but I could, and it would still yield x is equal to 5. Okay, you're still going to get the same answer, but if you need to make sure that you change it every time, then go ahead and change it even when it looks normal. Okay? This doesn't look normal. Okay? This doesn't look normal. All right, that's why I changed those, is because we don't really have a rule that we've been dealing with since first grade. This, we've been dealing with since first grade. You've had those problems. And when you switched it around like that, your teacher will go, that's impossible, you can't do that, that's wrong. Well, it's not impossible. I mean, it's not necessarily wrong. It was at that time of your life, but it's not necessarily wrong now. Okay? So those are the three different ways that we can look at that specific problem. All right, let's look at one that has subtraction in it and a negative in it. So, r minus 23 equals negative 6. Okay, all of these problems that we have, most of them are going to be just one step, solve it. Okay, when we're solving equations, there can be multiple steps of solving, and there can be multiple steps of simplifying before we solve. Okay, and we'll get into this whole next 5 or 6 sections in this chapter and the next section are dealing with those types of problems. It's going to be solving equations. They're going to gradually, obviously, get harder and harder as we get through each section. Okay, these first 2 sections are fairly simplistic. So, what do I do here? Copeland. Do what? All we got to do is, what is that sign? Subtraction, right? Okay, so what's the inverse of subtraction? Addition. So I'm going to add 23 to both sides. Over here it cancels, leaving me with r equal negative 6 plus a positive 23. So what is negative 6 plus a positive 23? 17. That is your answer. Now, remember why that is true. Negative 6 plus a positive 23, I have a negative and a positive, so therefore I have to take their absolute value. Okay, you're going to have to take their absolute value. Absolute value of negative 6 is 6, and I subtract the absolute value of 23, so it would be 23 minus 6. 23 minus 6, 17. And that's your answer. And it's a positive 17 because this has the larger absolute value. Okay? I'm just proving what a lot of you did in your head. Okay? I'm mathematically proving that negative 6 plus positive 23 is 17. Okay? Without actually showing the step in the equation. All right? I'm going to give you this one. I want you to try it on your own. 177 equal 403 plus W. Okay? Just because there's larger numbers does not mean anything changed. It's still the same process. When you get the answer, raise your hand. Only 3 of us? Joshua, hang on. Listen to my question. My question is your answer positive or negative? Negative. Okay. Copeland? Haley? You need to redo yours. All right, let's look at it. Obviously, you're still having some issues. Now, it doesn't matter that it's on the right side or the left side. Okay? This is the same thing as that. This is the same thing as the one we're dealing with. Any of those three are exactly the same. Okay? So if you see it, that's because it's addition. Okay? If this was subtraction, it would be similar, but I'd have to show you that one. Okay? So it doesn't matter which way we do it. The bottom line is, what am I doing to W? In that problem, what am I doing to W? Adding what? 403. I'm adding 403 to W. Okay, so what is the inverse of adding 403? Subtracting 403. So I have to subtract 403 from both sides of the equal sign. Over here, adding 403 and subtracting 403 cancel each other out, leaving me with W equals 177 minus 403. Well, that's 177 plus negative 403 equal W. Okay, I'm not done yet. I have to take, because of a negative and a positive, I have to take the absolute value of those two numbers and subtract them. Okay, when you take 403 minus 177. So that's just 403 minus that. Have to borrow from those two, making it 13, be 6. 9 minus 7 is 2. 3 minus 1 is 2. So 226. The larger absolute value is negative, so it's negative 226 equals W. Huh? Oh, yeah, you have to, you're borrowing from that, so it has to drop down 1, which would be 9. Okay, and so that would be your answer. Okay, then let's try another one. 216 equals U minus 129. Now, that is the same thing as U minus 129 equal 216. If it's easier for you to see and solve that way, that's fine. Okay, so find the easiest one you can see and then solve it. Okay, who has an answer for me? Gracie? What? No. Haley? No. Joshua? Yes. 345. Now, as if we look at this, you're subtracting 129. So the inverse of subtracting 129 is to add 129 to both sides. It cancels over here, leaving me with U is equal to 216 plus 129. When you put those two things together, you get U is equal to 345. Now, what did you do, Haley?
I added 216 or subtracted 216.
Okay. So you went 216 minus 129?
I subtracted, or I canceled out.
Okay, but you still wouldn't. See, that's the problem. You got to look and make sure, and this is how we've got to look at it. U minus 129 minus 129 equal 216 minus 129. That's what you're saying, right? Okay. Well, if I take $129 from you, and then I come back the next day and take another $129 from you, are you at a zero balance? You lost a bunch of money, right? Okay. If we look at it the other way, like I have done it, okay, now what this says is I took $129 from you, but the next day I felt bad about it and gave you back $129. Did you lose any money? No, you're just at zero, right? Didn't lose, didn't gain. That's why those two things cancel out, and those two do not cancel out. So you can't do that because they don't cancel each other out. That's the whole purpose of doing the inverse operation is that the two things cancel each other out. Like you have a big scale. I talked about this last year. Okay, and if I've got U and 129 boxes over here, okay, well, to get rid of those boxes, if they're negative, I have to have positive boxes. So I have to have a positive 129. But to make sure the scale doesn't, if I just do it on this side, then the scale is going to drop over here. And the scale over here is going to go up. So what I did to this side, I have to go back over here and do on this side as well. Okay, if I don't, then I'm going to have issues one way or the other. Okay, so you got to keep them balanced, and the only way to do that is by doing the inverse operation. Okay, let's look at this one. Negative 13 plus t equal 10. So what am I doing to the variable t? I'm adding what? I'm adding negative 13. So I am adding negative 13. So to solve, I must subtract negative 13 from both sides. Okay, I'm going to rewrite the equation. So I've got to I've got to subtract negative 13, subtract negative 13 from both sides. Over here, it cancels. So that leaves me with t is equal to 10 minus negative 13. That means t is equal to 10. Change that to addition. Do the opposite of that, which is 13. And so t is equal to 23. Huh? Not when, it's only when if it looked like this, yes. But that's not what that looks like. I have I have a subtraction and a negative sign, which is basically an addition sign. So I have to change it before I see. The only time I can follow those rules is if there's an addition sign there instead of a subtraction sign. This, you would subtract the absolute values. Okay. All right, let's look at number 27. Number 27 says, Copeland, when attacked by a giant hornet. Oh, no, my bad. It says, when attacked by a giant hornet, Japanese honeybees cluster, listen, when attacked by a giant hornet, Japanese honeybees cluster together to form a ball around the hornet and then generate heat by buzzing. The honeybees can endure temperatures up to 48 degrees Celsius, which is 3 Celsius greater than the hornet can tolerate. Okay? Find the maximum temperature tolerated by the Japanese giant hornet. Okay? So, once again, it says when attacked by a giant hornet, Japanese honeybees cluster together to form a ball around the hornet. So you have these little honeybees around this big hornet. Okay? Okay? So all these little honeybees are buzzing. Okay? Now, shh. They can buzz, okay? And they can withstand heat up to, the bees can withstand heat up to 48 degrees Celsius. Okay? That is, the hornet is equal to 3 degrees Celsius less than the bees. Okay? Or we can say it this way. What's the maximum temperature the bees can handle? 48 degrees. So 48 degrees Celsius is what the bees can handle. Okay? Do we know what the temperature is the hornet can stand? No. So we'll let that be H. Okay? H degrees Celsius is what the hornet can stand. And if I add how much to the hornet's temperature, it gives us the 48. 3 degrees. So, basically then, all I have is 48 is equal to the hornet's temperature that it can survive plus 3 degrees. Okay, so now I just solve it. So how do I solve it? No. Yeah, we subtract 3. Whether it's a word problem or whatever, it doesn't matter. It's just an equation. Okay, so I subtract 3 from both sides. That side cancels. 48 minus 3 is what? 45. So the hornet can stand 45 degrees Celsius is what the hornet can stand. Okay? 45 degrees is what the hornet can stand. No, it's totally something different, but I'm not going to put it down. Okay? So that's how you do those types of problems. All right? Now, your homework. 2.5, remember, it is 2.5, not 2.6. We're going 2.5, 11 through 30. And 32 through 35. Now, I want to show you number 34. Look, real quick, listen. So that's what 34 looks like. Okay? All you have to do is this. Subtract 9, it cancels. Subtract 9 over there. You get negative 7, and that leaves me at x minus 4 equal negative 7. Now, I add 4 here and here. Cancels, leaving me with negative 7 plus positive 4 would be what? -3. Okay? You may go,